During your lifetime, I'm sure that many questions have run through your mind, especially whether or not do varying South African environments affect the abundance of species, in particular one of mine and Africa's most loved species, the African elephant, Loxodonta africana. Monitoring the abundance of Loxodonta africana is important for acknowledging diminishing populations. Currently, Loxodonta africana is classified by ICUN as vulnerable. Hence, locating species increases survival rates by comprehending ideal habitats. A study was conducted to compare the abundance of Loxodonta africana in 2 locations located east of South Africa. Camera trap data entries were collected from the Tropical Ecology Assessment and Monitoring Team Network from the Udzungwa and Bindi impenetrable forest sites. Data was recorded during the South African dry period that occurs during July to October. However, due to the large data set collected from both locations, the raw data was narrowed down to a period of 3 years from 2010 to 2012. Furthermore, data was refined to site name, sampling period, number of animals, and sampling site for both transects. Statistical data analysis was conducted through a program RStudio to compare the richness of Loxodonta africana. In order to successfully monitor the populations of Loxodonta africana, comparisons of biomes are necessary for analysing abundance levels. RStudio was used for the following analysis of the data from the Udzungwa and Bindi impenetrable forest sites. A paired t-test found that the p-value was 0.011, indicating moderately strong evidence to reject the null hypothesis that environmental factors have no influence on the abundance of Loxodonta africana. Thus, there was moderately strong evidence to support that environmental factors at one site are preferred by Loxodonta africana. Furthermore, this evidence for a preferred site is also indicated from the mean of 127.67 from the Bindi impenetrable forest site compared with the substantially lower mean of 37.33 from the Udzungwa forest site. Box plots for both locations were compared. Udzungwa had a minimum of 6, first quartile 12, median 21, third quartile 62.5, and with a maximum of 101. The Bindi impenetrable forest had a minimum of 21, first quartile 51, medium 123, third quartile 159, and with a maximum of 246. Udzungwa median is very close to the first quartile, resulting in rightly skewed data with a short data range. Bindi impenetrable forest median is slightly towards the third quartile, resulting in left skewed data, with longer tails representing a larger data range. Density curves were used to examine the Loxodonta africana populations during 2010, 2011, and 2012. Udzungwa had a spike in density, however Bindi impenetrable forest showed a relatively constant density curve. Additionally, Udzungwa had total sightings of 560 at 3 sampling sites, and the Bindi impenetrable forest had only 1 sampling site, with a total of 1,149 sightings. In conclusion, environmental dynamics have major influence to the abundance of Loxodonta africana. The location of Udzungwa is in proximity to a relatively small township, including many roads and houses, thus a high rate of human disturbance and land degradation. Bindi impenetrable forest is recognised for supporting various diverse ecosystems and is protected as a UNESCO World Heritage Site. Access to this site is limited with no main roads near or through this site, resulting in minimal human disturbance. Higher populations of Loxodonta africana in Bindi impenetrable forest is in agreement with the outcomes of the data analysis. Consequently, it is a palpable observation that anthropological disturbances to ecosystems influence population size. Overall, the data analysis for the 2 locations in South Africa prove that varying environments do influence the abundance of Loxodonta africana.